everyone, in this video I'm going to go over your activity on pedigrees. In this activity we're going to be looking at several examples of pedigrees and how to identify using some common characteristics of what the different types of pedigrees or conditions of the pedigrees that we're looking at. In this first pedigree we're going to be looking at autosomal recessive. So with your autosomal recessive pedigrees, you need to remember that with the recessive condition, it's going to be hidden by a dominant allele or the dominant version of the condition. So in this example, I'm just going to simply use the letter A, and capitalized will be dominant, lowercase will be recessive. So on these pedigrees, the affected individuals are the ones that are shaded in, and squares represent males. Females are represented with a circle. So one of the clues you can use to determine whether or not this is autosomal recessive is that with these recessive conditions, it may skip a generation. And what we mean by that is you may see the traits. I'm going to follow this group right here as the example. So the grandfather here, number 1, had the condition. His daughter did not. But then number 17, this is the granddaughter of number 1. This person right here does display the condition. So what you'll see is what we call skipping a generation, because this individual doesn't have it, but this individual does. So when you're looking at the autosomal recessive, one of the characteristics that's going to help you to determine whether or not it's autosomal recessive is the skipping of the generation, because this individual here, since they are affected, the affected people are going to be, or whatever organism it is, the affected individuals are going to be little a. And so this person right here must have inherited one little a from the father and one little a from their mother. So I'm going to go ahead and write in the affected individuals, and then my unaffected individuals are going to have at least one copy of the dominant allele because they are not showing the condition. Now, I didn't write the second allele because I need more information to help me understand whether or not an individual is homozygous dominant or heterozygous. And so we use evidence from the tree to help us understand that situation. For example, with number 2 here, each of these children has at least one dominant allele. So they must have gotten the dominant allele from this person, but from their mother or their father, they must inherit one small a, because that's all that this person can produce in the gametes. So I don't have enough information to determine what this individual is, and so I'm going to just leave it as a blank. Again, I can't tell whether or not this person is homozygous dominant or heterozygous because these children aren't giving me any clues. Person number 3, on the other hand, I do have some information about this individual. We know that they have at least one dominant allele because they don't have the condition, and they were able to pass that dominant allele to number 9 and number 12. However, number 10 and number 11 are evidence for this person's genotype. Because these individuals inherit one A from their mother, they must have inherited the second little a from their father. So I'm going to use number 10 as evidence for number 3 because this is a direct child. This person I can't use as evidence, even though I mentioned it. I actually can't use this person as evidence because they are not a child of this person. However, number 10 here did get one of these small a's from the father. More specifically, number 10 inherited one small a from the father. Therefore, the father must be heterozygous. And you can use that reasoning and logic as evidence for justifying the genotype of a person. So let's take a look at number 8 here. Let's pretend for a moment that we did not know number 8's genotype. So we know for a fact that they are unaffected. So we would put a big A. And now we're going to find evidence to support their genotype. Well, there's 2 ways we can do this. We can either use the person's offspring, number 17, as evidence. And the way that we would do it is we would say that number 17, this person must be heterozygous because their child, number 17, must have inherited one of their recessive alleles in order to be affected. The second piece of evidence that I could use is number 8's father. Because the father could only donate a recessive allele, number 8 can only inherit a recessive allele from the father. They inherited the dominant allele from their mother, and so this person must be heterozygous and is not affected by the condition that they're looking at here. So that's the 2 ways you can justify a person's genotype, is by looking at what did they pass on to the next generation, or what did they inherit from the previous generation. I hope this video was helpful. This is part 1 of your pedigrees. The other videos are going to be much, much shorter because I won't go into as much detail about setting this up. So this is the first video. Thanks for watching. Bye.